example, you have 1 carton of full cream milk and another bottle of mango juice, right? So my question to you is, what is the density, what is the volume, right, that is available for the carton of full cream milk, and what is the volume available for the container carrying the mango juice? A tip. Volume is basically how many liters or milliliters can a container take, right? How many milliliters of water or gas, right, can a container take? So, answer me in the chat. Can you guys see that? I just hope you can see it fine. I'm going to zoom in. Okay, Quentin, well done. So milk is 1 liter. It can accommodate for 1 liter of a liquid, right? And as we see that the mango juice container here can contain 1.5 liters of juice, okay? So that is what we call the volume, right? How much space can be taken up by a container, all right?
Ma'am?
Yes?
But they normally fill it a bit less. So they'll say it's 1 liter, but it can actually say like hold 1.2 liters usually.
Oh, so you're saying less or more?
They fill it up less, so actually
Yeah.
the size, how you can if you fill it up to the max, it's height.
Oh wow.
To avoid spillage.
Okay. Yeah. Thanks for that, Quentin. That makes sense. I mean, actually, that's a very good point because the entire container can accommodate for 1 liter of liquid, right? But obviously, if they have to fill it right to the top, it's going to spill. Yeah. All right. So, guys, moving on. I just have a few points to discuss with you guys, and then we can get to an activity, right? So it says here, the high density of a solid material explains why it cannot be compressed. Okay, so because if you remember from solids, liquids, and gases, we learned that solid particles are really, tell me two structural functions of a solid particle. When you look at a solid or you have to draw like the diagram, what are 2 characteristics of the solid particle? And I want answers from Muawiyah because I haven't heard much answers from you last week or this week.
There are now, ma'am.
Yes. Can you tell me what are the 2 characteristics of a solid? What makes it so rich?
The solid, when you put it into a liquid, it becomes a liquid.
It becomes liquid. What else? Tell me with regards to arrangement of particles.
And you put water in your what you call in those freezer trays, in your freezer tray, and you put it in the freezer, it becomes a solid.
Okay, and Sarah says particles are compact and can't move freely. Excellent, Sarah. So in a solid, we know that there's not much space. Actually, there's like no space, right? The only space is maybe there's a little bit of a space, right? Depending on what kind of solid you're talking about. Okay, and the particles are vibrating. They're not like physically moving like that in a liquid would do. Yeah, and they pack together, right? And that's what makes them have a smaller volume. They take up a smaller volume of space. They take up less space than a liquid would take up, right? But if we look at a liquid, if I pour like water into a pool, the water's not going to like freeze magically on one side of the pool. It's going to spread out and take up the shape of that pool. So with regards to this point here, because solids are so like packed together, compact, as Sarah says, that's why we can't compress it. Okay, so if we take maybe like a few chalk pieces, put it in a syringe and we try to push it, there's just so much that it can be compressed, right? Just remind me again, what does the word compressed mean? When you compress something, what are you doing to that substance?
You're making it smaller by pushing molecules closer together.
Oh, well done, Quentin. I love that answer. Well done. So, like Quentin says, when you're compressing a substance, you're pushing the molecules together, right? So any space that's available, those molecules are going to push into that available space. And in a solid, there is not much space, right? Very, very small amount of space. So that's why it cannot be compressed. The particles in a solid are tightly packed. Okay, we read that. But liquids, on the other hand, are also very dense. And why are they dense with regards to volume? Whenever I speak about volume, when it comes to density, I'm talking about the space, okay? Think about the space between particles when I talk about volume. So there also is not much space between particles of a liquid. That's why liquids are also very dense substances, right? The density of a liquid is roughly the same as the density of a solid of the same substance. So, you know, if I take an ice cube, right, and I melt it, the densities are more or less the same, but we'll come to how ice can differ. Okay, this is because their particles are close together, even though they are not locked into a fixed position. Most liquids cannot be compressed into smaller volumes, right? Why can it not be compressed into smaller volumes? Tell me in the chat.
Because there's very minimal space, and the space that the molecules are vibrating.
Okay, well done, Quentin. Because just like a solid, there's not enough space for the particles to move, right? Liquids are slightly less dense than their solid states, but water is an important exception. So what we're saying here is that the general rule is that solids are more dense than liquids, right? But in the case of water, H2O, the liquid of water is more dense or denser than the ice cubes, right? And we're going to learn why that is, right? And one important characteristic that tells you that ice cubes are less dense than water is the fact that they float on top of the water, right? You're never going to have an ice cube that sinks to the bottom. Why is that? Because just like your body, when you're floating in the sea or in your pool, you don't just sink to the floor, right? You actually are picked up by that water, right? Because the water is heavier than you are. So let's go into that a little bit. If we look at an ice cube, right? If we really zoom into it at a molecular level, we are going to see something like this. But what do you guys notice from this diagram here? Is this like looking like a typical solid structure? Tell me in the chat. And I want those who have been quiet. Jensen, Ethan, Watupa. Chloe says no. Yeah, I agree. It's not a typical solid structure. What tells me that it's not typically solid? It's not a fixed shape. Well done. Why is it not a fixed shape? Oh yeah, you can't just tell me no. You need to give me a reason for why you say no. Okay, so Sarah says they're not closely together as a normal solid.
I
Excellent.
meant no for the other one, ma'am.
Okay, even so, right? So yeah, so that's exactly why this is not a typical solid, because can you see the gaping holes in between the particles? All right. So this is amazing, because what happens when water is frozen, or when it's freezed, the particles start expanding. And when we say expanding, they move away from each other. Okay, so have you ever had an ice cube, and maybe if you were thirsty, but it doesn't really quench your thirst because it feels like it looks huge, it may look huge, but when you actually suck on it, you're not intaking much water because it looks big, but there are more spaces in ice cube than there is in the liquid state of water. And Chloe says there's still gaps in it, which means it's not a proper solid. Well done, Chloe. But if I look at the molecular structure of liquid, right, of liquid water, I see that. What do you guys see now? Tell me about the spaces.
Ma'am,
Yes.
it's tightly packed. Isn't it tightly packed?
Yeah.
There's not enough room to move.
Excellent, Chloe. I love that. So it's tightly packed and there's not enough room to move. Well done. Basically, no spaces. Good, Sarah. So that's why, if you drop a few ice cubes into your little glass, or maybe you're having like a cold frappe that day, right? Then the cubes are going to float on the surface and never sink. Now, let's go to other examples of, when we mix water with other substances. So have you guys ever tried doing that experiment where you take different substances and you put it in a jar, right? So maybe you put like honey and oil and water and food coloring, and then you start developing layers of colors. Have you guys ever tried that? Maybe in school or at a science experiment? Just repeat who you are, because you guys are sounding the same. Is it Quinn?
It was Las Vegas. But
How are you?
I'm well, and how are you?
Good, thank you. You have classes today?
I have a class now.
it was my school run.
Yeah. Sorry.
It was my school run, man.
Yes, that
I
was.
just heard a voice.
Yeah. All right. So Chloe says she has done it before. Tendo says LOL. Yeah. So guys, it's a really cool experiment, and I think I know you guys love doing experiments, and your parents probably shout you for playing around with the kitchen stuff. But anyway, I think it's very important that you try this experiment and I'm going to give you guys the details of the experiment over the weekend. Yeah, and you just, see how a whole lot of substances are put together. And because they have different densities, right? If we look in the case of oil and water, this is a glass filled with oil and water. Oil will always rise to the top of water, even if you try mixing it. Okay, it will never dissolve within the water. All right. Can anyone tell me with regards to density, why is it that oil floats on the surface of water and doesn't sink or mix with the water, or diffuse with the water?
It's not close.
In the chat? Tell me with regards to density, right? Density has to do with volume and has to do with mass. Okay, Sarah, you can answer me. You can turn off your private chat there. Yeah, so because oil is lighter than water, when I say lighter, what do I mean, guys? Tell me about volume.
It
Tell me
doesn't weigh as much.
it doesn't weigh as much. What does that mean? Taylor says the water has more density. Remember, density is made up of two components, right? Volume, which has to do with the space between particles, and mass, which has to do with how many particles there are. Tell me about the volume and tell me about the mass. Of particles. And I'm not hearing much from Ethan and Jensen. Guys, are you there?
No, ma'am, I'm not sure.
Are you not? Oh, that is good to know, hey? It's so good to know that you're not there. Sarah says volume, it's not as close as a solid would be. Well done, Sarah. So, guys, when we're talking about density, whenever I ask you to talk about the density of an object, right, or a subject, all you need to do is tell me about volume. Volume has to do with the spaces, right? And tell me about mass. Mass has to do with how many particles are available. All right. So because oil has a smaller volume, or rather a larger volume, sorry, the particles are further spaced out, right? And obviously it would have less particles, therefore it will be lighter and it will float to the top of the water. Right, and I even put a little scale here for you guys. Oil floats on water for two reasons. A cup of oil has less mass than a cup of water. The oil is less dense than water. When I say it has less mass, I'm not saying that it weighs heavier, right? Because weight has to do with gravity. But I'm talking about the individual particles and how many particles there are. If there's more particles in one substance than another, then that will usually be more denser, right? This makes oil float in water like a cork or an air-filled rubber duck floats on the surface of water. Secondly, oil does not dissolve in water. The oil molecules cluster together and float on the surface. If a large amount of oil is poured into water, the oil spreads out and forms a layer on the surface of water. Oil that is spilled into the ocean or a lake spreads over a huge area. It poisons many animals, birds, fish, plants, and is very expensive to clean up. That is why oil pollution has an extremely negative impact on our environment. Have you guys ever seen those pictures where they show you how the entire bird's feathers are soaked in sea oil, in oil from the ships?
Yes, ma'am.
And isn't it a horrible, terrible sight? Because that poor bird can never fly because it has oil stuck in its feathers, right? So it's quite a sad sight. All right, guys, and the next thing we're going to talk about is we have learned that the density of a material depends on how tightly packed the particles inside the material are. The more tightly packed they are, the more dense they are, right? Or the more particles we have, the more dense it is. The following diagram represents a container on the left that contains a small amount of gas. Imagine that all the gas from the small container is moved to an empty container on the right. Draw the gas particles in the container on the right. So we're not going to draw it, but what happens if I empty all of the gas in here and into this container on the right? What happens? Tell me about the spaces. Will there be more spaces or less spaces? It will be widely spread out, even more so, right? And I like the diction Sarah is using. She's saying spread out. So gases like spreading out to every part of the room that they are in. That is a picture of a oil spill. Thank you, Tendo. We should check it out. We will check it out now. So a gas will expand to fill whatever space it is in. In the larger container, we will still have the same number of gas particles, but now they are filling a much larger space, right? If we take a certain amount of gas from one container and place it into another larger container, the gas expands to fill the large container. The same mass of the gas is now in the larger volume. The gas now has a lower density. So can you guys see how two things, I measure density with two things, volume and mass. Mass has to do with the number of particles. So which container, right, after I move all the gas from the small one to the big one, will have a higher density? Answer me in the chat. You all can answer this one. Even if it's wrong, just say it so I know that you're trying. Okay, well done, Sarah. So the container on the left has a higher density. Why? Because it has a smaller volume, right? There are smaller spaces, okay? And yeah, there's smaller spaces. So in both containers, there'll be the same amount of mass, but the thing that changes is volume. Now you have a bigger space, right? And think of density as being like, have you guys ever tasted, obviously you have, tasted chocolate cake that's like very moist and dense, and sometimes brownies that can be heavy, right? Why do we say that they are dense? Because they are like so densely packed with a whole lot of like chocolate and cake and stuff like that, right? But then if you've eaten, you know, let's say a Lay's crisp, and the packets are like so, you know, they're filled with, they have a lot of volume, but there's not much chips in there, right, guys? It's quite funny, actually. Yeah, so solids and liquids cannot behave in this way. Their densities will remain more or less constant no matter in which container they are placed. This is because their particles are relatively close together with strong forces between them. But what happens when we heat them? We have learned this in this. This is the same as giving them extra energy. All right, so don't worry about that. So basically what we're talking about here is if we have a liquid in this container, right, let's say, and we transfer the liquid from the small container to the large container, is the density going to change? Tell me in the chat. And tell me why. If you say yes or no, yes, the density changes, tell me why. No, the density does not change, tell me why. And this is for a liquid, right? And I want answers. I want answers from Matupa. I haven't heard anything from you. I want answers from Jensen. Hello, Jensen. Hi.
What is the question again?
Okay, so let me repeat the question. If hypothetically I had water in the small container and I transferred the water from this container to the big container, how will the density change? Will the density change, right? When I transfer the water? If yes, tell me why. If no, tell me why. Okay, Sarah says yes, there's more space. Who else? I'm only going to answer you guys after at least 3 more people answer me. Kendo says no, because the water is the same amount. Sorry, that was Ethan that answered me. Sorry, Ethan, I thought it was Sarah. Thanks. And I will give you feedback on your comments now, right? And one more person, Jensen. Yes, because it has more space. Okay. So guys, from the three of you, I have to agree with Tendo. Now this is why, right? When we take water, like water from, just say, okay, from the small container to the big container, right? Water is going to drop to the bottom. Maybe it's gonna fill up until here, this point here, right? Water is not like gas. It doesn't have the same property where it spreads out to the entire container, right? So what water will do is it will stay in one, it will drop to the bottom, right? Because it has a higher density. But the densities will not change when I change it, when I take it from this container and drop it into the next. Why? Because if you look at that space of water that's in here, right, still has the same amount of spaces, still the same type of spaces, and still the same amount of particles. Does everyone understand this? Can everyone positively say that you understand why?
Yes.
Cool. Cool. Awesome. Right, moving on. We're nearly done with the lesson.
Yes, ma'am.
Right. So, guys,
Yes,
in this activity, this is what you guys are going to do for homework, but let's discuss it now, right? And then you guys can write your answers for homework. Okay, number 1 says, compare the 3 identical containers below, A, B, and C. They all have the same volume and contain the same material, right? So let's say that all 3 of these are, I don't want to say water, but let's say it's oil, right? Let's imagine that it's oil. So here we have oil in like a butter form. Here we have oil in a liquid form, and here we have oil that's evaporating, right? Whenever you fry something, you see the steam that comes up. That's actually the oil that's evaporating. Okay. So tell me about when I say that it has the same volume. What do I mean by that? When I say that all 3
It
of
has
them,
the same amount of capacity.
okay, well done, Tendo. And what Tendo is basically meaning is that it takes up the same amount of space. So the block for each of these particles or substances are the same size, right? Not, you would say it has the same space for the particles to submerge, basically. Okay, so container A contains a solid, container B has a liquid, and container C is a gas. Answer the questions that follow. Question number 1. Which container, A, B, or C, contains the greatest number of particles? In the chat.
A.
Well done, A, right? In the chat. Good, guys. 2. Which container contains the smallest number of particles?
B.
Okay, well done, guys. It's C. And number 3, which container A, B, or C contains the material with the greatest mass? And how do we calculate mass? We think about which one has the most number of particles. Yeah, so
A.
it's A, right? Well done. Okay, which container has the smallest mass and why do you say so? Still in the chat, do not answer me verbally. Okay, Sarah says C because it has the less amount of space. And there's one more answer. There's less, actually there's more space between particles, right? It has less particles. Well done, Tendo. Moving on. Which state has the highest density? Is it solid, Liquids or gases? And you can't just tell me A, you need to tell me A because this and that. Okay, wait, so Ethan says C because there's more space and less particles. Yes, Ethan. So here we are number 5, right? And no, yes, the solid has the highest. And whoever's yawning like that. Solid because it has more particles and no space. Well done! Oh my gosh. Yeah, well done. I wish there was like a little emoji that I could use here. And I was really happy with you guys' answers. I'd like post a sticker. That would be cool. All right. And the last question. Which state has the lowest density? And why do you say so? Remember, there are always 2 reasons to explain density. Okay, Quentin says there's more spaces available between particles in C. Well done. And the next one is that there are particles roam freely and there's less particles than the other containers. Well done, guys. So that is the end of our lesson, and I hope you guys learned. With regards to English, you guys have a book review due for Monday.